North Carolina has specific electrical licensing requirements that must be met to legally perform electrical work. North Carolina does not reciprocate electrical licenses from other states. Therefore, to wire up a home in North Carolina, it's necessary to obtain a North Carolina electrical license. The process involves several steps. Firstly, it's important to meet the eligibility requirements. These include being at least 18 years old, having at least 4 years of electrical experience, and passing a background check. Secondly, apply for a trainee license. This involves submitting an application to the North Carolina Electrical Contractors Licensing Board, also known as the ECOB, and paying the application fee. Thirdly, complete pre-licensing training. This typically requires enrolling in an approved electrical pre-licensing program, which is approximately 250 hours in length. Fourthly, pass the journeyman exam. This step involves scheduling and successfully passing the North Carolina Electrical Journeyman's Examination. Fifthly, obtain a journeyman license. To do this, submit a completed application with proof of training and examination results and pay the license fee. Sixthly, work as a journeyman for at least 3 years. This requires gaining supervised experience under a licensed electrical contractor. Seventhly, pass the administrator exam. This involves scheduling and passing the North Carolina Electrical Administrator's Examination. Eighthly, obtain an administrator license. This entails submitting a completed application with proof of training, examination results, and journeyman experience, and paying the license fee. North Carolina does not have a reciprocity agreement for electrical journeymen. This means the full licensing process must be completed to work as a journeyman in the state. North Carolina does not have a reciprocity agreement for electrical administrators either. A North Carolina administrator's license must be obtained as detailed above. Here are some additional resources to consider. The North Carolina Electrical Contractors Licensing Board website can be found at ncelp.org. The North Carolina Building Code Council website is buildingcodecouncil.org. And lastly, the North Carolina Electrical Contractors Association website can be found at NSECA.it. The North Carolina Electrical Code adheres to the National Electrical Code, often referred to as the NEC. This code provides standards for safe electrical installations. Some key areas covered by the NEC include general requirements, wiring and protection, wiring methods and materials, equipment for general use, special occupancies, special equipment, and communication systems. General requirements cover topics such as conductor sizing, overcurrent protection, grounding, and bonding. These requirements ensure that electrical systems are installed safely and function properly. Wiring and protection address the proper selection and installation of conductors, cables, and raceways. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect against overloads and short circuits. Grounding and bonding are essential for safety, providing a low impedance path for fault currents and minimizing the risk of electric shock. Wiring methods and materials cover the types of wiring allowed in different locations and under various conditions. This includes information on cable types, conduit systems, and wiring installation practices. Equipment for general use addresses the requirements for electrical equipment such as luminaires, appliances, motors, and transformers. These requirements ensure that equipment is properly installed and safe to use. Special occupancies cover locations with unique electrical hazards such as hazardous locations, healthcare facilities, and places of assembly. Special equipment addresses the requirements for specialized electrical equipment such as electric signs, elevators, and data processing systems. Communication systems cover the installation of wiring and equipment for communication systems such as telephone, data, and cable television. North Carolina's adoption of the NEC ensures uniformity and standardization in electrical installations across the state. It is important to be aware of local amendments or additions to the NEC that may be specific to North Carolina. These amendments can be found on the North Carolina Building Code Council website. Navigating the NEC effectively involves understanding its structure and how to find specific information. The NEC is divided into chapters, articles, and sections, each covering a specific topic. The index is a valuable tool for locating information quickly. It is organized alphabetically and provides references to specific sections within the code. The table of contents provides a comprehensive overview of the entire NEC, allowing one to quickly locate the chapter or article relevant to their needs. Annexes provide supplementary information such as examples, calculations, and guidelines. These annexes can be helpful for understanding and applying the requirements of the NEC. Understanding conductor ampacity is crucial for proper wire sizing and preventing overheating. NEC Table 310.15b16 provides ampacity ratings for various conductor types and sizes, based on their insulation temperature rating and ambient temperature. Correction factors are applied when the ambient temperature exceeds 30 degrees Celsius or 86 degrees Fahrenheit to reduce the ampacity rating of the conductor. Adjustment factors are applied when multiple current-carrying conductors are bundled together in a raceway or cable, as the heat generated by each conductor can affect the ampacity of the others. Grounding and bonding are essential for electrical safety. The grounding system provides a low-impedance path for fault currents, allowing overcurrent protection devices to trip and clear the fault. Bonding ensures that all metallic parts of an electrical system are electrically connected, minimizing the risk of voltage differences and electric shock. NEC Article 250 provides detailed requirements for grounding and bonding. Overcurrent protection is designed to protect electrical circuits and equipment from overloads and short circuits. Circuit breakers and fuses are the two most common types of overcurrent protection devices. Circuit breakers are resettable devices that trip when the current exceeds their rating, while fuses are one-time devices that must be replaced after they blow. NEC Article 240 provides requirements for overcurrent protection. Understanding voltage drop is important for ensuring that electrical equipment receives the proper voltage. Excessive voltage drop can cause equipment to malfunction or fail. NEC Informational Note Number 4 to Section 210.19 AM provides guidelines for voltage drop, recommending that the voltage drop on branch circuits not exceed 3% and the voltage drop on feeders not exceed 5%. Calculating voltage drop involves considering the conductor length, current, and resistance. Wiring methods and materials must be selected based on the specific application and environment. Common wiring methods include non-metallic sheet cable, also known as NM cable, electrical metallic tubing, also known as EMT, rigid metal conduit, also known as RNC, and flexible metal conduit, also known as FMC. Each wiring method has its own advantages and disadvantages, and the NEC specifies the allowable uses for each. Electrical boxes are used to enclose wiring connections and provide protection for devices such as receptacles and switches. NEC Article 314 provides requirements for electrical boxes, including their size, construction, and installation. Boxes must be sized appropriately to accommodate the number and size of conductors they contain. Boxes must be securely mounted and properly grounded. Special occupancies, such as hazardous locations and healthcare facilities, require additional electrical safety measures. Hazardous locations are areas where flammable gases, vapors, or dust may be present. NEC Articles 500 through 516 provide requirements for electrical equipment and wiring in hazardous locations. Healthcare facilities require special electrical systems to ensure patient safety. NEC Article 517 provides requirements for electrical systems in healthcare facilities. Special equipment, such as swimming pools, spas, and hot tubs, also require additional electrical safety measures. NEC Article 680 provides requirements for electrical equipment and wiring in these locations. Ground fault circuit interrupters, also known as GFCIs, are required to protect against electric shock in wet or damp locations. In North Carolina, electrical inspections are conducted by local government agencies or third-party inspection agencies. Inspections are typically required for new construction, renovations, and electrical system upgrades. The purpose of the inspection is to ensure that the electrical work complies with the NEC and local codes. To prepare for an electrical inspection, it is important to have all necessary permits and documentation. The electrical work should be completed according to the NEC and local codes. The electrical system should be tested and verified to ensure that it is functioning properly. Common electrical code violations include improper wiring methods, undersized conductors, inadequate grounding, and lack of overcurrent protection. Correcting electrical code violations typically involves redoing the electrical work to comply with the NEC and local codes. This may involve replacing wiring, adding grounding, or installing overcurrent protection devices. Continuing education is essential for staying up to date on the latest electrical codes and technologies. The NEC is updated every 3 years, and electrical codes and standards are constantly evolving. Electrical contractors and electricians should participate in continuing education courses and seminars to maintain their knowledge and skills.